Okay, so today we're going to learn about the basics of matrices. And the basic idea behind a matrix is matrices were really used to kind of be able to put things in a simpler way without all this extra fluff. So if you took like, let's say you had these two equations that you were using and you wanted to kind of put it into a nice format that's easy to read. What you generally would do is you would just take out since these letters are always going to be the same, you don't really need to have these letters or variables every time. So you just kind of convert it to being like 2, 3, and 4. And then the second line be like 6, -4, and 0. And so you can convey all the same information you have here that takes up more room in a simpler way that looks like this. So that's the main idea behind matrices, is just making things that take up a lot of space be smaller and simpler and more compact. We're going to learn some rules and techniques in what these different things are called, but that's the basic idea behind it. Let's just look at this matrix here, and let's talk about how we would describe it. Matrices we describe by their rows, by their columns. So in this matrix, I would call this thing a 2 by 3 because it has 2 rows and it has 3 columns. So this is a 2 by 3 matrix. And inside the matrix, you have these things called elements. Every single number is an element. So let's say this is matrix A. And I might ask a question like, hey, if this is matrix A, what is the element 2, 1? Well, again, matrices are always rows, then columns. So I'd go to row 2, which is right here, and column 1. So that would be 3. Let's say I had another one that I wanted to know, like A, 2, 3. Well, again, for this one, I'd go to row 2 and then column 3. So that number would be 0. Let's say I went A, 1, 2. Well, for that, I would go to row 1 and then column 2. So that would be -4. So you can kind of see, again, when we talk about matrices, we always just use this row by column method to describe them. Let's take a couple and see if we can say what type of matrices they are. Okay, so again, let's say what type of matrices they are. This is 1, 2, 3 rows, so it's a 3, and then 1, 2, 3 columns by 3. This one would be 1, 2, 3 rows by 1, 2 columns, so it's a 3 by 2. This one is 1, 2, 3 rows by 1 column, so it's a 3 by 1. So you can see labeling these matrices are pretty easy. And then the elements, like if I labeled this one A, this one B, and this one C, if I wanted the element C to 1, we'd go to row 1 down to row 2, column 1, and we'd get element 2. Okay. So again, this is kind of how we read matrices and how we put in all this information into matrices. Okay, so there's two new things we're going to talk about, is 2 operations. We first want to talk about the identity matrix. And then we're going to talk about scaling. The identity matrix. This is the matrix that we use to times by 1. So you know how everything has like 5 times 1 gives you 5? Well, you always want to have some number that when you times by something, you get the same kind of output. And that's what we call the identity matrix. The identity matrix looks like this. That's for a 2 by 2. it would be this for a 3 by 3. It'd be this for a 4 by 4. And you can see how I'm making them. It's just like it's a whole bunch of zeros with diagonals. Now you can't have an identity matrix. Whoops, that last column I kind of messed up. You can't have an identity matrix that is not what we call a square matrix, meaning it has the same number of columns it has rows. So identity matrices are all these matrices that have the same number of columns of rows. Like identity matrix can't be this. So you can't have a 2 by 3 identity matrix. It just doesn't exist. It has to be one of these square kind of things. So that's essentially how you use a matrix to times by 1. So if you have a 2 by 2, you can times it by 1 by using these identity matrices that we call right here. An identity matrix, again, is just diagonal ones and zeros to fill in the rest. And we'll see why when we do matrix multiplication of why this works out so nicely. Let's talk about scaling. Scaling is used to not multiply matrices, but to kind of increase the size of the matrices by multiplication. So this isn't matrix multiplication, but this is kind of increasing the size of the matrice. So when we scale something like 5a, what we really want to do is we want to take every element in here and times it by 5. So for this one, if I did 5a, we would have 10, 20, 15, -5, 0, and 25. If I wanted to do negative 2a, we would take every element and times it by -2. So you get -4, -8, -6, 2, 0, and -10. So really how this scaling stuff works is it's just timesing every element on the inside and kind of increasing it. That's kind of the basics of matrices. Again, matrices are just a simpler way or a more compact way of holding just the numbers and taking out all the variables or units that you have attached with the different things. And then you get a couple things with these. One thing that you get is you can scale these things. You have its own identity matrix, and then it has its own number system, like how we always go row by column. Okay, so this is a really important idea that you know all these things so that when we talk about them, we all have this common language. So try the different problems today. If you get stuck, just let me know.